Now let's continue with our lecture video in integral calculus, now with the topic application of definite integral volumes of solids of revolution by integration. Now a solid of revolution is generated by revolving a plane area about a line called the axis of rotation in the plane. The volume of the solids of revolution may be found with one of the following methods. Number 1, we have the disk method. Number 2, we have the ring or the washer method. Number 3, we have the cylindrical shell method. So we will discuss how these three methods differ from one another. So let's take the first one. We have the disk method. The disk method is used when the axis of rotation is part of the boundary of the plane area. So let's consider this figure. We have here the boundaries of the curve, the y-axis and the x-axis. Now, using all three boundaries, we will have the area of this shaded portion. Now the question here is, if we rotate the one of the boundaries, which is the x-axis, if we rotate the x-axis, it will form a figure of a paraboloid if our plane area is a parabola. So rotating the x-axis will form a figure which is a paraboloid. So how will we get the volume of this paraboloid? Now one method is the disk method because the area strip that we were going to use is perpendicular with the axis of revolution. So our axis of revolution is x-axis, and the area strip that we will use is this one here, the small width dx and the length y. So we have the area strip y dx, and it is attached so here in the x-axis. Now if you rotate that plane, that area of area strip there, it will create a figure which resembles a coin. So rotating the x-axis will create a disc or a coin. Now how do we get the volume of a coin? So here is the formula. So we have here volume of a coin is equal to the pi multiplied with the radius squared and the thickness of the coin or the disc. Now using the area strip, we will have the volume as pi y squared, y being the radius, and dx being the thickness of the disc or the coin. Now to get the volume, given the limits of x1, y1 and x2, y2, then we now have the formula volume is equal to pi integral of y squared dx from the limits x1 to x2. So that's the formula to be used if we are considering the x-axis as the axis of rotation, and the method used is the disk method. Now how about if we use the other boundary? So we have the other boundary which is the y-axis. So if we use y-axis as the axis of rotation, then we will have here, in this figure, we will have a horizontal area strip. If we are considering the disk method, then we have a horizontal area strip. So this area strip is attached to the y-axis. Now, if you rotate the y-axis, it will create a coin or a disc. Again, using the formula for coin or a disc, we have there volume is equal to pi r squared times the thickness. And if we use integration to get the volume, we have there volume is equal to pi. So we have there x squared dy. Then the limits are y2 to y1. Why y2 to y1? Because y2 here is lower compared to the y1 here. Remember that this is the lower limit and this is the upper limit. So from our previous video, it would be helpful if we watch the how we get the limits in solving plane areas. So that's for the disc method. Let's go to the second method, the ring or washer method. The ring or washer method is used when the axis of rotation is not part of the boundary of the plane area. So if the axis of rotation is not part of the boundary of the plane area, and then the area strip is perpendicular with the axis of revolution, then we will have the ring figure. Why? Because if we take x-axis as the axis of rotation and the area strip as perpendicular to the axis of rotation, then if we rotate this, we will form a ring or a washer with a hole in the middle. Now, how do we get the volume of a ring or washer? So we have there volume is equal to pi r outside squared times the thickness. So the radius outside or the outside radius minus the pi r squared t or thickness of the hole. So we have there the radius of the hole or the inside radius. Now if we use the area strip y dx, then we have the thickness as the dx. And here the y becomes the r outside squared minus r inside squared. Now, using integration to get the volume of the washer, we now have volume is equal to pi integral of r outside squared minus r inside squared dx from x1 to x2. So because we're using dx, therefore the limits are x. And the lower limit is always lower in value compared with the upper limit. Now how about if we take the y-axis as the axis of rotation? So the same boundaries of so we have here the boundaries of curves, two curves here, and then we have the area strip which is perpendicular to the axis of rotation. So again, we will form a ring or washer here, and using the area strip x dy, we now have the volume of the ring or washer as pi integral of r outside squared minus r inside squared dy. Therefore, the limits are y1 to y2. So why we use y1 to y2? Because y1 here is lower compared to the y2. Let's go to the third method. We have the cylindrical shell method. So cylindrical shell method is used when the area strip is parallel with the axis of revolution. Take for example this axis of revolution x, axis, and we have the boundaries, the curve, the y, and the x-axis. Then we have this area here. So to take the volume that is formed, which is the paraboloid, we can use the horizontal area strip x dy, and notice that it is parallel to or parallel with the axis of revolution. Now, how do we get the volume of a shell or a can? So how do we get the volume? So it is an open can, open at the top, open at the bottom. So we have here the formula. Volume is equal to 2 pi r. 2 pi r being the circumference multiplied with the length or the height of the can or the cylindrical shell, then multiplied with the thickness of the can or the shell. Now using the horizontal area strip, that becomes 2 pi x or 2 pi y. That's actually 2 pi y, y being the radius. Then we have the height as x and the thickness as dy, or that is volume is equal to 2 pi xy dy. Now to get the volume, given the limits x1 y1 and x2 y2, we have here the volume is equal to 2 pi integral of xy dy, and since we are using dy, the limits are y2 to y1. y2 is lower, that's why it is in the lower limit, and y1 is greater, that's why it's in the upper limit. Now, when we use the y-axis as the axis of rotation, and the area strip parallel to it is y dx, therefore, we will use the formula 2 pi integral of xy. The difference is we will use dx. And since we're using dx, the limits are x1 and x2. Okay, so those are our methods and formulas to be used. Let's answer or solve the examples. There are 6 of them. Okay, for example number 1, we have the area bounded by the parabola AY is equal to x squared, the axis, and the line x is equal to b, and it is revolved about the x-axis. Find the volume generated. Now, it is of great help if we practice solving for the plane area first, so that solving for the volume becomes faster. The reason is we will be looking for the limits, which we will be using for the formulas of the volume. Okay. So first, we will be sketching the curve using this equation here. So we have y over x. So using ay is equal to x squared. If y is equal to 0, therefore x is equal to 0. If y is equal to a, then so if y is equal to a times a is equal to x squared, a squared is equal to x squared, therefore x is equal to positive or negative a. So this is positive or negative a. Then it says here So let's have another one here. Let's use 2a. If we use 2a, so we have here a, 2a is equal to x squared. We have 2a squared is equal to x squared. Therefore, x is equal to square root of 2. That will be 1.41a. So this is 1.41a. Next is, it says there, x is equal to b. So if x is equal to b, what is y? So ay is equal to x squared, ay is equal to b squared. So y is equal to b squared over a. So this is b squared over a. Okay, so let's sketch the curve. So we have here the x and y axis. So since we are sketching, so even though we don't get the perfect sketch, at least, or perfect figure, at least we were able to sketch it. So if we say this is a to a, this is a to a. So let's have the curve at AA. And then we have here, we have negative here, this portion. Then we have here 2a 1.41. So we have 1.41 here. So imagine this, we still have, so we have another one here, the left side. Then if x is equal to positive b, notice that there's no b here. So meaning it's anywhere on the positive side of the x-axis. Let's say somewhere here. So that is x is equal to b. Then let's sketch the curve. It's going to be something like that. Okay, so it's not perfect as I said a while ago. At least we were able to sketch it. So we will be finding the volume generated if it is revolved in the x-axis. So this is the x-axis and this is our axis of revolution. If we are revolving here and these are our boundaries, so this is the curve, the line, and the, okay, so did not mention the x-axis. It mentions the axis. The question here is, are we going to include this part in finding the volume generated? The answer is no. We will just concentrate on this portion here because the one of the boundary is x is equal to b. So x is equal to b. Then this is the line y is equal to x squared is over a. Now if we are using the x-axis as the axis of revolution and decided to use the area strip, okay, we decided to use the area strip here. So we have here y dx as the area strip. Therefore, the method that we will be using is the disc or the coin method, the disc method. Okay. Now, what is the formula for the disc method? So we have there pi integral of y squared dx if we are using the vertical area strip. So we have the limits, the points here, 0, 0. And then we have here, this is x is equal to b, therefore y is b squared over a. And we now have the volume is equal to pi integral of y squared dx, x1 to x2. Then we have the y as the upper limit minus the lower limit. If you notice, the upper, y upper, and then y lower, that I say. That is pi integral of y upper is x squared over a minus y lower is 0. Then that is squared dx, x1 is 0, x2 is b. So that is equal to pi integral of x raised to 4 over a squared, 0 to b. This is dx. Therefore, we have here pi, so this is pi x raised to 5 over 5a squared, 0 to b. Let's continue the solution here. So that is equal to, let's remove the constant, pi over a, well, let's include 5, so 5a squared. Then we have here the upper limit first, substitute to x, the variable x. So b raised to 5 minus 0. Therefore, volume now is equal to pi b raised to 5 all over 5a squared cubic units. So that's our volume. Now, if we decide to use the horizontal area strip, so using the same figure for the boundaries, and then we decided to use the horizontal area strip, and that is x dy. So if we rotate the area strip in the x-axis, it will form a shell. So the first one here is the disc method, and then this time we will use the shell method. Now, if we are using the shell method, so the formula that we are going to use is, and then we have the x-axis as the axis of revolution. So we have volume is equal to 2 pi xy dy. And then the limits are y2 to y1. So we have their volume is equal to 2 pi xy dy. Let's have their y1 to y2. And then notice here that we need to satisfy the condition that x here is not just simply x. X here is x right minus x left. It is connected to the boundary x is equal to b and the curve x is equal to square root of a y. So we will now write this as 2 pi integral of x right minus x left. X right being b minus x left is square root of a y. Or This is, let's just say, ay raised to 1/2. Then we have the y. So, retain y, dy. So, you just leave it as it is because we just need to convert x into y so that we can solve the integration here. Okay? Therefore, the limits, so we have the limits here as y1, which is 0, and then y2 is b squared over a. So we now have 2 pi integral of by minus, we have a 1/2, then y raised to 1/2 plus y times y, that becomes 3/2 dy. So the limits are 0 to b squared over a. So volume now is equal to 2 pi is equal to by, that means by squared over 2 minus, this is a raised to 1/2, y is raised to 5 over 2 over 5 over 2. The limits are 0 to b squared over a. Then we will substitute first the upper limit minus the lower limit. So, okay, I think we still have space here. 2 pi. So we have the b multiplied with b squared over a squared over 2 minus, this becomes 2/5 a raised to 1/2, and then we have here b squared over a raised to 5 over 2. Let's use this extra space here. Then we have now 2 pi, and this becomes square, so this becomes b raised to 5. So b raised to 5 all over 2a squared minus, we now have here 2 times, so b raised to 5 all over, so this becomes 1/2, so this is 5/2. So I'm looking at this portion here. So this is a raised to 5 over 2 minus 1/2, this is 4 over 2. So this becomes a, or 5a squared minus, so we have here minus 2 pi, so 0 over 2 minus a times 0 over 5 over 2. So let's cancel that to 0. So what's left is, we have here, so what we have here is pi b raised to 5 over a squared minus 4b raised to 5 over 5a squared. So volume now is equal to, so what is 5 minus 4? So that becomes, oh, this one here is 4 pi. That becomes 4 pi b raised to 5. Okay. So that becomes now pi b raised to 5 all over a squared, or 5a squared cubic units. This is similar with the answer for the first method. Okay, so that's for number 1. Let's go to number 2. We have here the area bounded by the parabola AY is equal to x squared. The axis and the line y is equal to b revolve about the x-axis. Find the volume generated. So again, we will sketch the curve. So using this equation here. So let's sketch the curve using the points we can get. So we have y over x. So ay is equal to x squared. If y is equal to 0, then x is equal to 0. If y is equal to a, then x is equal to a. If y is equal to b, so a, b, x squared. Therefore, x is equal to square root of ab. So if y is equal to b, x is ab raised to 1/2. Okay, so let's sketch the curve. So all positive. Well, again, this value of x is positive, negative 1. So if we sketch here the curve, positive or negative 1 for x. But line y is positive. So let's put it here. Again, this is a sketch. So this is, let's say this is a, negative a, 2a. Then this is a, then 2a. So we have here the point now. If we use 2a, we have positive, negative 1.41a. So we have here 1.41a. Okay, so we have this curve, and the line is somewhere here in the y-axis, and it is positive. So let's say here, let's take this line as that is the y is equal to b, and this curve here is the ay is equal to x squared. Okay, this is y and then this is x, and then says there the axis of revolution is the x-axis, so we revolve it here. Okay, so if we use here so let's put first the points. So this is AB squared. So this is square root of AB and then B. Point here. Okay, so if we use here the horizontal area strip. So if we use the horizontal area strip, therefore we will use the shell method. So we will use the shell method. And the formula is v is equal to 2 pi integral of x, y, then this is x dy. So therefore we use dy. And the limits y1 to y2. Okay. So we will retain y dy, and we need to substitute for x to become y. So to do that, we have here in the figure 2 pi, then x right minus x left, x right. So that is square root of a y, or that is a y raised to 1/2 minus x left 0, then y dy. Limits y1 as 0, y2 is b. Okay, so let's use this extra space here. So that becomes 2 pi. And we integrate that. That is, or before we integrate, 0 to b. So that is a raised to 1/2 y raised to 3/2 dy. Therefore 2 pi a 1/2, then y raised to 5 over 2 all over 5 over 2. Limits 0 to b. Then we need to substitute. This is 2 pi a raised to 1/2. Then we now have here b. Okay, so this becomes 2/5. So this is 2/5. Then b raised to 5 over 2. So therefore, we can have the volume as 4 over 5 pi, then 5/2 minus 1/2 is 4 over 2. That is b squared. Then what's left is ab. So we can have this as an answer. Don't forget cubic units. Okay, so that we have the answer as volume is equal to 4/5 pi b squared square root of ab cubic units. Let's take another approach. So the shell method is because we use the horizontal area strip. Now how about if we use the vertical area strip, which is y dx? If we use the horizontal area strip or the vertical area strip, and then this is the axis of rotation, then what we have here is a ring. So it has a hole in the middle. So we will be using the disc method. Then using the disc method, so where's our disc method? So we have here ring outside minus ring inside, both squared. And then since we're using a vertical area strip, so we have here dx. So volume is equal to pi integral of r outside squared minus r inside squared dx. Therefore x1 to x2. What is our r outside? Our r outside is technically the y upper. That is the r outside. Our r inside is technically the y lower. Why did I put it there? So if we put it in the formula, our r outside is equal to the y upper. The y upper is b. That's simply b squared minus r inside the y lower, which is the curve, and that is y is equal to x squared over a. So we have here x squared over a squared dx. The limits are 0 to square root of ab. So 0 to ab raised to 1/2. Okay, I think we got what we needed in solving. So we have here 0 to ab raised to 1/2. So this is b squared minus x raised to 4a squared dx. This is pi b squared x. So b squared x minus x raised to 5 over 5a squared. The limits are 0 to ab raised to 1/2. So we now have pi. So b squared multiplied with ab raised to 1/2 minus ab raised to 1/2 all raised to 5 all over 5a squared minus pi of, that is already b squared times 0 minus 0 raised to 5a. So we have here equal to pi. So this becomes, so this is a raised to 1/2, then b raised to 5 halves pi minus, this is pi over 5. What becomes with a is, so 5 minus 4, so a raised to 1/2, then b is raised to 5 over 2. So we now have the volume equal to 4/5 of pi, again b squared square root of ab cubic units. Alright, so it's similar so with the here. So that's example number 2. Take note that we get the same value because we are considering the same so the same areas. And by the way, I forgot to mention why I took the first quadrant. It's because the boundary of the plane area is the parabola, and the axis. This is their axis, the plural of axis, meaning the boundary includes the y and the x-axis. So we are just concentrating on the first quadrant because we are including the y-axis as the boundary. Okay, forgot to clear that a while ago. So that's the example number 2. Now we have here example number 3, the area bounded by the parabola x squared minus 2x plus y is equal to 3. The y-axis and the line y is equal to 4 revolves about the line y is equal to 4. Find the volume generated. Again, let's sketch a curve. So we have here yx. Then we will be using the equation x squared minus 2x plus y is equal to 3. Y is equal to 3 minus x squared plus 2x. So if x is equal to 0, then y is equal to 3. If x is equal to 1, then y is equal to 4. If x is equal to 3, so we have here 6, 3, 9, 6, negative 6. So therefore, y is equal to 0. If x is equal to negative 1, therefore, we have here 0 also. Okay. Therefore, we can now sketch the curve. So, all positive here. And then, we have here the y. If we take this as, if this is 1, 2, 3, 1, so 1, 2, 3, 4. So this is negative 1. So if x is equal to 0, y is equal to 3. If x is equal to 1, then y is equal to 4. If x is equal to 3, then y is 0. Same with x is equal to negative 1, y is 0. So, can form here a parabola. Now, how about so this is the boundary. That's the boundary, the parabola. Check. The y-axis. So, this is the other boundary, the y-axis. And the line y is equal to 4. So, we have another boundary, the line y is equal to 4. So, there we go. Therefore, the area we are considering here is this portion. So, this is the area that we are considering. Now, what is the axis of rotation? It is revolving around the line y is equal to 4. So, this is y is equal to 4. And the axis of rotation is here also. Now, if we take here so let's put the limits first, the coordinates. So we have here 0, 3, and here we have 1, 4. So we plan on using the vertical area strip. So we have here dx and we have y. Okay. So this is now our y is equal to 3 minus x squared plus 2x. Then if we are rotating on the y is equal to 4, then the figure, what we can form here is the disk. Therefore, we will use the disk method. Using the disk method, we have the formula. So, pi y squared dx. Volume is equal to pi integral of y squared dx. The Therefore, we have here x1 to x2. Then, we need to convert this into x. Therefore, we will substitute there the y upper minus the y lower. Our y upper here is 4. So y upper here is 4 minus the y lower is 3 minus x squared plus 2x. Then we will close it with squared dx. Now, if you've been noticing, when it comes to this method, we got the square outside the parentheses. Compared with the, this should be ring method. Sorry about that. So, compared with the ring method, so the ring method has the squared inside the parentheses, each on the radius. So, each on the radius. That's for the ring method. Now, for this method, it's outside the parentheses. So, we have here the y upper minus the y lower. So, pi x1 to x2 y upper minus y lower squared dx. And also use that as a pattern. Okay, and then the limits are, so we are going to use x. The limits are 0 to 1. And if you notice, we can already use our calculator here. So we can input the calculator. So we have here the integral sign here. So 4 minus parenthesis of 3 minus alpha x squared plus 2 alpha x. Now again, this is if we are allowed calculator. And I find this as easier because it's definite integral. I think I need to put here another parenthesis, and then squared. Then lower limit 0, upper limit 1. We're using degrees here. So we have here 0.5. So did we use the proper formula? Plus 2x. So 0.2. So we have here 0.2. So volume is 0.2, or that is pi over 5 cubic units. Now we use the vertical area strip. How about if we are going to use the horizontal area strip? We're going to plan and use the horizontal area strip. Then, what we are forming there will be the shell. Now, take note that if we use the shell, that is 2 pi xy dy. We're going to use the shell method, and then we need to convert here or substitute x with y. So there's no problem with the x right, because x right will become 0 minus x left. How do we get the x left? How do we get the x of this equation? So it will be more complicated. That is why instead of using the shell method, then we will just settle with the disk method. So that's for number 3. So answer is pi over 5 cubic units, or 0.2. Let's go to number 4. Find the volume generated by revolving around x-axis the area bounded by x squared plus y squared equals a squared, and the x-axis. So again, let's sketch the curve. This is y, x. Then using x squared equals a squared minus y squared. Okay? If y is equal to 0, then x will become a, positive or negative a. If x is equal to 0, therefore y is positive, negative a. Okay, so let's try to sketch that. Therefore, if we put here a, negative a, positive a, this is also a. This is also negative a. What we have here is a circle. So the limits are, the points are a. So if y is equal to 0, x is positive or negative a. If x is equal to 0, positive or negative a. So what we have here is a circle. And it says here that the axis of revolution is the x-axis so what we're forming here is a sphere. So let's see if we can derive, or we can get the volume of a sphere. So if we're concentrating on the find the volume generated by around the x-axis bounded by this curve and the x-axis. If we are considering the boundaries, it says there the x-axis and the curve. That means the area that we are considering is half the sphere. So we are considering only half of the circle, or yeah, half of the circle. I should say half of the circle. So the points are, we have here negative a, 0. This is 0a, and this is a, 0. Now if we use the easiest, most probably area strip here, that would be the disk method. So we have here y dx, and that is this method. Volume is equal to pi y squared dx. This is x1 to x2. Okay, therefore we now have here, if we want y to become x, therefore this is, so y squared is equal to a squared minus x squared, or that is y is equal to square root of a squared minus x squared. So So this is pi integral of square root of a squared minus x squared raised to 2 dx. x1, we will consider the farthest here. We have negative a to a to a, negative a to a. So that is equal to pi integral of negative a to a. This becomes a squared minus x squared dx. We have pi pi x negative a to a minus pi x raised to 3 over 3, negative a to a. Okay, so this is now equal to pi a squared. First, the upper limit, a, minus the lower limit, pi a squared negative a, minus pi upper limit minus pi negative a as the lower limit positive. This is pi a raised to 3 minus, we have here pi a raised to 3 over 3 negative, pi a raised to 3 over 3. So this is equal to 2 pi a raised to 3 minus 2 pi a raised to 3 over 3. That is 6 minus 2, that is 4/3 pi a raised to 3 cubic units. And this is the formula for a sphere having a as the radius. Okay, so that is correct. That's for number 4. Let's go to number 5. Find the volume generated by revolving about the line x is equal to 2a, the area bounded by that line, the x-axis, and the curve a squared y is equal to x squared. Again, let's sketch the curve. So we have here, using a squared y equals x raised to 3. If y is equal to 0, then x is equal to 0. Okay. If a or x is equal to a, y is equal to a. If x is equal to 2a, therefore y is equal to 8a. Okay, so let's sketch the curve. So all positive. Again, we have here, if this is a, this is 8. So let's put here 8a, and this is 2a. This is a, and this is a. Therefore, we have here points for the curve. So we now have the curve a squared y is equal to x raised to 3. So this is a squared y is equal to x raised to 3. This is the line here. And then the curve. The line here is 2a. So we have here 2a. So that's the line. So x is equal to 2a. So let's see the boundaries. We have the boundary, the line, the x-axis, and the curve. So we're considering this area here. 0 to 0, 0, 0, and then this is the point here. Oh, so it should be, so my sketch is wrong. It should be here. Okay. So the point here is 2a, 8a. Okay. So if we are considering the line as the axis of rotation, so we are rotating it here. Let's take as an area strip the horizontal area strip. So we are considering the horizontal area strip rotating in the line x is equal to 2a. Therefore, we are using the disk method. And we have here x dy, the area strip x dy. Right? So using the disk method, volume is equal to pi x squared dy, x12, x2. Take note that the x here becomes x right minus x left squared dy, x12, x2. This pi integral of x right, our x right here is 2a, minus the x left. Our x left will be a squared y raised to 1/3 squared dy. Oh, it should be, the limits are wrong. It should be y. The reason is we are using dy. So it should be y1 to y2. Okay. So our y1 here is 0 to, our y2 is 8a. 8a. Okay. This is pi integral of, so this is 2a minus, this becomes a raised to 2/3 y raised to 1/3 squared dy, 0 to 8a. Therefore, this becomes, we expand this. So if we expand this, we will have here 4a squared minus, becomes 4. This is a raised to 5/3. Then y raised to 1/3 plus a raised to 4/3, then y is raised to 2/3 dy, and 0 to 8a. So that is equal to So if we derive this, if we integrate this, the answer will become 4a squared y minus 4a raised to 5 third y raised to, this is 3 over 3, this is 4 third, plus a raised to 4 third y raised to 5 over 3 over 5 over 3, 0 to 8a. So substitute, we will be substituting here. So since the lower limit is 0, so I will no longer expand that, it's already 0. So 4a squared, y is 8a minus 4, this is actually 12. So cancel, this becomes 3. This is 3, a raised to 5, 3, y is 8a, 4 third plus 3 fifth, a raised to 4 third, then 8a raised to 5 over 3, then minus 0, of course. So that is equal to, so that becomes 32. So that is 32 pi a raised to 3 minus 48. This is 48 pi. So what will happen here is 4, so 9. So this becomes a raised to 3 plus, this is what is 5 over 3 of 8. Okay, so we have here 96 over 5 pi a raised to 3. So volume now is 16 over 5 pi a raised to 3 cubic units. So that's the volume for this method. Now if we plan to use the vertical area strip, so using the same boundaries, so if we are using the vertical area strip of the y dx, and then the rotation is in the here, the line. Oops. And therefore, we will have a shell method. So we will be using the shell method. So the volume here is 2 pi integral of xy dx x1 to x2. Then we need to remove y. So we need to substitute y with x. So we have here the y upper minus the y lower. 2 pi. So y upper minus y lower. X dx x1 to x2. So we have here the y upper as x raised to 3 over a squared minus 2a x dx. Then x1 is 0, x2 is 2a. So that is equal to 2 pi. So this becomes here. By the way, are we going to settle for x dx? Because remember, when we derive the volume of a shell, the x here is the radius. But what if the rotation is in the line? So we have here as the x. This is the x here, from the origin to the area strip. If this is 2a, here, therefore, the radius, this portion here as the radius, is equal to 2a minus x. That's the radius of the shell. Therefore, here, this is not just x dx, this is actually 2a minus x dx. This is very important because if you become used to just using x dx or y dy and forget the principle on how we derive the formulas, then you might get the wrong answer. So the reason why 2a minus x here instead of x is that we are taking the radius of the shell that is formed. Okay, so if we substitute here, so why did I put here 2a? So this should be 0. Y lower, this is the y lower, so this is 0. So we distribute that, we have there 2x is a, then this is a, and then minus, we have here x raised to 4 over a squared dx 0 to 2a. Okay, then let's use the extra space here. Now we have equal to 2 pi. This becomes 2. Okay, so this becomes 2x raised to 4 over 4a minus, this is x raised to 5 over a squared, 0 to 2a. And substitute the value for 2a. This is 2 pi. It's 2 times 2a raised to 4 over 4a minus 2a raised to 5 over a squared, then minus 0 equals, so we will now cancel here 4. So what is 2 raised to 4? 2 times 2, 4 times 2, 8 times 2, 16. So we have here 16 a raised to 3 pi minus, we have here 16 times 2, so we have here 16 times 2, so 32 times 2, 64. 64 a is to 3 pi all over and did we forget something? Yeah, we forgot to put 5 here. Forgot to put 5. Should be 5 here. This is 5. Therefore, the volume now here is equal to, this is 16 over 5 pi a raised to 3 cubic units. So it's similar with the this method, the answer for this method and then the shell method is the same. So that's for number 5. That's for example number 5. It would be easier if you're computing for definite integral and not the a or b, so that we can use the calculator. So let's see for number 6, the last problem. We have number 6. Find the volume generated when the plane area is bounded by y is equal to negative x squared minus 3x plus 6 and x plus y minus 3 is equal to 0. It is revolved about x is equal to 3. Finally, definite. Okay, first we need to sketch. Okay, the first one, we will be using the first equation. We have there y is equal to negative x squared minus 3x plus 6. So if x is equal to 0, y is equal to 6. If x is equal to negative 1, y is 8. If x is equal to negative 3, y is 6. Then if x is equal to 1, y is 2. I think it would be easier if we compute for the point of intersection. Why? Because we are considering two. We have here the curve and the line. So let's look for the point of intersection of the two boundaries. So let's use the line x plus y is equal to 3. Therefore, y is equal to 3 minus x. Substitute that on the curve. The curve here is y is equal to negative x squared minus 3x plus 6. Substitute y, we have 3 minus x is equal to negative x squared minus 3x plus 6. Therefore, we now have x squared plus 2x minus 3 equals 0. So we have x plus 3, x minus 1 is equal to 0. Therefore, we have x is equal to negative 3 and x is equal to 1. At x is equal to negative 3, y is y is equal to 6. So that is at x is equal to negative 3. At x is equal to 1, we have 3 minus 1. So y is equal to 2. Therefore, the points of intersection are P1, negative 3, 6, and then P2 as 0.12. So these are the points of intersection. Then, we can solve for additional points. So here are the additional points. So we're done with the curve. Let's go to the line. So yx, if x is 0, y is 3. If x is negative 3, y is 6. If x is equal to 1, y is 2. Okay, now let's sketch the curve. Sketching the curve and the line. Okay, so I think we can use this space here. Alright, so we have there the points. So if we have here, if x is equal to 0, then we have here the point as, for example, let's sketch the highest point for y is 8, and then it is on negative 1. Then we have here 6, let's say this is 6. And then at x is equal to 1, we have here y is equal to 2. So if you can see, I'm just doing some sketches. So here we have y is equal to 6. Okay. This is our curve. There you go. That is our curve. Oops, almost. So that's our curve. Then next we need to find the line. Sketch the line. Our line has the boundary negative 3 and 6 and 1, 2. So this is the line. So that's the line. Because this is point. This is point negative 3, 6 here. And then this is point 1, 2. And the problem says the plane area bounded by the curve and the line. So this is what we are going to consider. Alright, and then where is the axis of rotation? The axis of rotation is about x is equal to 3. That's the axis of rotation. Then let's use a different color. Say here, if x is equal to 3 as the axis of rotation, then this is the x is equal to 3. So x is equal to 3, and then this is where it is revolving. Okay, so this is our line. Y is equal to 3 minus x, and this is our curve. Y, so y is equal to negative x squared minus 3x plus 6. Okay, and we're going to use first the area strip. Now watch where I put the area strip if I'm considering the vertical area strip. Now why am I going to consider the vertical area strip? Now this is discussed in the video plane areas. The reason is this is y dx. We are considering y dx as the area strip. That means our limits are x, the points x. If we are considering the limits x, so these are the boundaries, we can take the whole area. Now if we use the horizontal area strip, now we will be violating one of the rules, and that is this point here. It touches the boundary twice. That's why we're not going to use the horizontal area strip on that portion. Now how about here? Now if we use here as the position of the area strip, then we have two different boundaries. The problem is this is x dy. If that is x dy, therefore the limits we're going to use are the points y. And look at these points y here. This is the lower limit. This is the upper limit. That means you will just consider this portion only. And we will leave this area here. So we will not get the accurate answer. That's the reason why in this problem, I'm considering the vertical area strip. Now, if I'm using the vertical area strip, and this is the axis of revolution, the volume generated is that of the shell. We're considering the shell method. The shell method rotating here, so it will form a shell here. If that's the case, look at the radius. This is the radius that we're going to consider. Oops. So this is our radius. Okay, let me explain what's going on here. Alright, so this is our radius. This is the radius that we need in solving for the shell method. Now, this is the total 3. From the origin up to the location of the area strip, that is x. Therefore, the radius is 3 minus x, and not just x only. Another reason why I put the area strip on the positive x axis, or on the first quadrant, is if I put the area strip here, then we have the radius as bigger, so that's more complicated now. Now let's just stick to the positive one. So there we go. That's our radius for the shell method. Now if we are considering the shell method, therefore the volume here is 2 pi integral of xy dx. And if this is dx, the limits are x1 to x2. Now, we will remain or let x here. No, this x here is the radius. Invert y. Okay, so we now have here 2 pi. The y here, this is actually 2 pi integral of the y upper minus y lower, the x as the radius dx, x1 to x2, radius dx or simply x dx. Okay, because this y upper y lower is the height of the shell, cylindrical shell, and then x is the radius. Right? So we have here the y upper. The y upper is the curve, and that is negative x squared minus 3x plus 6 minus the y lower is the line 3 minus x, and we have the radius as 3 minus x dx. Limits x1 negative 3, limit x2 1. Okay, then we can already use here the calculator actually, but let's simplify further if we want to, because the calculator will occupy this portion here, so we cannot see much. This is 2 pi, but you can already calculate or input this in the calculator if you want. So we have here negative x squared minus 3x plus 6 minus 3 plus x, 3 minus x dx, negative 3 to 1, this is 2 pi, 2 pi integral of, this becomes, so 3 minus x, then this is negative x squared minus 2x plus 3 dx, negative 3 to 1. And let me just put it here. So that we can see what's going on with our calculator. Alright. So we now have here 3 minus alpha x. Remember, we are using degree mode here. Then negative alpha x squared minus 2 alpha x plus 3. Going to the lower limit, negative 3. Then upper limit 1 is equal to, that is 128 over 3. So we have here volume is equal to 2 pi 128 over 3. So that is 2 times 128. So that is times 2. 256 pi over 3 cubic units. So that's for the volume. Okay, so that's for number 6. Okay, that's all for this video.